All right, so today we are going to be now writing the equation from the graph. So last lesson you were graphing from the equation. Today we're going to go the opposite way. So to be able to write a quadratic equation in vertex form, remember vertex form is y equals a times x minus h squared plus k. And a lot of this equation is the same every time. The only pieces of information that we need are this a, h, and k value. So to get those, the first part is that vertex, which is the h and the k. So if we know the vertex, we know the h and the k value. And then the second piece is we need to figure out what the a value is. So that's how we're going to write our vertex form. So if we're going to figure out our vertex, and then we're going to figure out our a value. So in this case, our vertex is that bottom of our graph. So in this case, it would be 2, 0. And then remember when you were graphing, your a value determined if you went over 1, up 1, over 2, up 4, over 3, up 9. And then if you had an a value, these values changed. So all we're going to do is determine how much these values changed by. In this case, we went over 1, up 1. So our a value is still 1 because these rules over here stayed the same. If I went over 2, up 4, I have another point on my graph. And that point's actually right there. I went over 2, up 4. I would end up right there. So our a value in this case did not change. It follows these rules over here. So if I write that out, I would have y equals 1 because a is 1. Let's write out the equation first and then we can practice replacing. So our equation is y equals a times x minus h squared plus k. So we know that a is 1. So we're going to write 1, and then I have x minus, and then h is the first value of our vertex, right? This is h and this is k. So h would be 2 and k would be 0. So now to simplify this, I don't need to have the plus 0. I also don't need to have this 1 in the front. I can keep it if I want, but I don't need to. So the most simplified version would be x minus 2 squared. This would be the most simplified version, but I would also accept this one or this one. All right, so let's practice that again. So if I go over here, remember the two things to write it in vertex form, you need the vertex and the a value. So my vertex is that bottom of the graph. So in this case, that's 0, 0. And then I want to see, did my graph go over 1 and up 1 like it normally does? Or did that change? So if I go over 1, up 1, I'm not really on that graph at that point. I went over 1 and up 2. So I went over 1 and up 2, which means that my a value was in fact 2 instead of 1. Right? My a value increased by 2. Instead of being at 1, 1, it's now at 1, 2. So all my a values got multiplied by 2. Right? If I go over 2, I had to go all the way up 8 instead of up 4. So my a value in this case is 2. So my vertex is 0, 0, and my a value is 2. So I would have y equals, this is not writing well, so let me try again. Y equals a x minus h squared plus k. So a is 2. And then h is 0, that first number of my vertex, and k is 0, the second number of my vertex. So if I want to simplify that, x minus 0 is the same thing as just x. So this is actually going to simplify to y equals 2x squared, and then I don't need that plus 0 on the outside either. So this is what we started with and is correct in vertex form, and this is just the simplified version of that. So either one of those looks fine. All right, so if we look at 3 and 4, we're doing the same process. So remember, there's two pieces of information you need. You need your vertex and you need your a value. So my vertex in this case is down here, so that would be at 0, -5. And my a value, so I want to check, did I go over 1, up 1? If I did, that means I have a normal a value of 1. If I didn't, that means my a value changed. So I went over 1, up 1. I could check the other one. I went over 2, up 4, right? That's the next one. So since those are true, that means that my A value was 1. Nothing changed about my A value. So then my vertex would be, my vertex form, A is 1, so this is 1. The first number is my H value. The second number is my K value. And if you write plus -5, that's the same thing as just writing -5. So when I simplify, I don't need that 1 in the front. I also don't need that 0. So this would really simplify to x squared, right? X minus 0 is just x. So then I have x squared times 1 is just x squared. And then plus -5 is the same thing as -5. So I'd probably just write it as a -5. So again, this is my most simplified form. All right, so if we look at number 4, again, I need my vertex and my A value. So my vertex is at -4, 0. And my A value, I want over 1 and up 1. So that means my vertex stays 1. So then my vertex form would be y equals 1 times x minus -4 squared plus 0. So then a negative and a negative turn into a positive. So that becomes y equals, I don't have to write that 1 in the front, but I can. And then I don't need to write that plus 0 on the outside either. So this would be my most simplified form. All right, so if you want to pause the video and try 5 and 6 on your own, go ahead. If not, we're going to go over those next. So we're doing that same thing. The only difference in number 5 is that graph is upside down. And if you remember from the notes from last week, if we have a negative A value, that's when our graph flips over. So I know, before I know the value of A, I already know that it has to be negative because my graph is flipped upside down. So my vertex in this case is 0, 0. And then I know my A value is negative since my graph is upside down, but I have to figure out, is it -1, -2? What's that negative number? So did it go over 1, down 1? Let's see, it went over 1. It didn't go down 1 because that doesn't connect at that 0.11. It actually went over 1 and down 2. So that means that this value was multiplied by 2, which means my A value is -2. Right? My graph was stretched by a value of 2. It went down 2 instead of down 1 like it normally does. So when I write that out, I would have y equals, and then my A value is now -2, x minus 0 squared, because my vertex is 0, 0, plus 0. So that's my vertex. So then if I simplify, remember, I don't need to include these zeros. So x minus 0 is just x. So I get y equals -2x squared, and then I don't need to include that plus 0. So this would be my simplified form. All right, so one more if we go to number 6. So I need my vertex, and I need my A value. So my vertex is right here at 1, 1, and my A value, so did my graph go over 1, up 1? Yes, it did, so that means that the A value is just 1. So I have y equals 1 times x minus 1 squared, right? This goes inside my parentheses, this one goes on the outside. And then the only thing we could do to simplify is we don't need to write that 1 here. So I could just write it as x minus 1 squared plus 1. If you want to leave the 1 in the front, that's completely fine. But remember, 1 times anything is just whatever you're multiplying by. So that 1 doesn't affect our answer. All right, great. So we finished 214. So then I want to look at a couple problems on page 217 and 18. So let's move on to those. So on page 217, I want to go ahead and look at number 6 because that one's a little tricky. So let's look at that one. So on this page, they're asking you for the transformations, which on the previous page we hadn't used to help us graph, but we can. It can be a really helpful tool because a lot of our transformations actually go into making the equation. So if we think about the transformations for this graph, right, if my vertex is right here, so my graph is flipped upside down, which means it's reflected, and we know that that means that our A value, right, because to write our equation we need our vertex and the a value. That means that because it's flipped upside down, our a value is negative. So reflected graphs give you a negative a value. Then I can see that my vertex, which is normally at 0, 0, went left 8, so that's my transformation, and up 3. And that's going to affect that vertex, because now my vertex, instead of being at 0, 0, is at negative 8, positive 3. And then the last piece here then would be to find that a value to see if that graph stretched at all. So if I look, my graph should go over 1, down 1. So if I go over 1 and down 1, I'm still on my graph. So that just means my a value is negative 1. So these transformations kind of help us write the pieces of information we need for our vertex form. So just a reminder, our vertex form is y equals a, x minus h squared plus k. Our vertex is the h and k value. This is h, this is k. So when I write this out, I have y equals negative 1, x minus negative 8 squared plus 3. And so then the only thing I would really do to simplify is turn these two negatives into a positive. So I get x plus 8 squared plus 3. So this would be my simplified form. Yeah, so writing out those transformations don't necessarily help us write the equation exactly, but they give us tools that we need and give us insight to that information. So let's go ahead now and look at number 10 on page 218. This one's a little tricky as well. So let's look at this one together. So again, when I'm writing out those transformations, it's giving me information about my vertex and about my a value. So remember, the first big piece of information is this graph is upside down. So that means this graph has been reflected across the x-axis. So that means that a value is negative, right? When we reflect, when it flips upside down, our a value is negative. Oh, my screen just flipped over. We should be back in business now. Let's see. Okay, sorry about that technical difficulty, but now we should be on a normal looking screen. Okay, so that reflected made our graph negative. So then if we look for our vertex, normally our vertex is at 0, 0, and now it's here. So it went right 2 and up 3. So that's going to tell us that our vertex went right 2 and up 3. So it's at the value 2, 3. And then the last thing we need to figure out is, did our graph stretch any? So is it going over 1, down 1, over 2, down 4? So let's check. If I go over 1, I don't get to go down 1. That didn't work. So something had to have changed. So if I go over 2, I ended up going down 2, right? If I look here, if I go over 2, I only go down 2 before I end up at this point. So 4, I didn't go down 4, I went down 2. Well, what does that mean for our a value? That means that our a value was split in half. So instead of going over 1, down 1, I went over 1, down a half. And then instead of going over 2, down 4, I went half of 4, which is 2. So that means that my a value is a half. So I am at negative 1/2, right? Because I went over 2, down 4, or over 2, down 2, instead of over 2, down 4, that cut this value in half, right? Half of 4 is 2. And if we look, if I went over 1, I'm about halfway between the down 1 that I was supposed to go. So that gives me the a value of negative 1/2. So it was stretched, right? My transformation is it's stretched by 1/2. So these are those two pieces of information that we needed, and we get them from that list of transformations, and now we can write the equation. So I have y equals negative 1/2 x minus the first value, so x minus 2 squared, plus that second value of my vertex, which is 3. So this would be the equation of that graph. So hopefully, with the help of this video, you can finish pages 217 and 218 and turn those into me. Make sure you check your answers. The solutions are posted, so make sure you check your answers. And then if you have any questions, stop by those Zoom that Zoom time that we can go over problems together. So hopefully this helped. Go ahead and finish page 217 and 218 on your own.